So we are here to train you guys on one of your latest procurement, which is the Nicolet iS50 FTIR Spectrometer. So the Nicolet iS50 is Thermo Scientific top-of-the-range FTIR Spectrometer. It starts from a basic configuration. It can be configured from a very capable system. So what we're going to go through in the next minutes or so, a few minutes, is we're going to focus on some of the hardware capabilities of the system and what modules you can configure it with. And one of the main focus will be the TGA IR module, because this is one of the probably one of the things that you mentioned you're going to be requiring for your application. So as you can see here, this is probably one of the only FTIR spectrometer in the market that you can have as much as 7 sampling stations. So in this particular photo, you see the iS50 with a Raman module, with a built-in ATR, a GCIR module, and an NIR module. So what you're seeing here is the heart of the system, but the possibilities you can do with the system is sort of unlimited. So the main configuration, so this photo shows the basic system. So, and what you're seeing here is, we start here from the touch point system. So this particular touch point is quite programmable. The software, which is Omnic, which drives the system, is highly customizable. We can create macros, which will allow you to create workflows. So if you want to create, if you do routine measurements and including data analysis, an operator simply needs to do is walk up the system. If he's got gloves and all of that, touch this, and that particular touch point will do a series of functions depending on how this is programmed. And I'll show you how to do that later on. The main component, or where your sample goes through, is what we call a sample compartment. So this is the sample compartment. So what we have here is a standard transmission sample holder. So typically your film, powder, or nodule molds, if you remember your second year chemistry, or sometimes you'd make KBR windows and all of that. Typically that will go through here. And I'll show you later on the beam path or the beam diagram that the Nicolet iS50 uses. What we have here in this section of the spectrometer, in the front section, is we have the detector position. So it's a triple detector system, so we can configure this with as much as 3 detectors for infrared data collection. So we've got typical detectors you can use, DTGS detector for room temperature measurement. You can configure this with an MCT detector if you want more sensitive measurement, but in your particular application, as per our discussion, DTGS detector will suffice. But in the future, shall you need a more sensitive detector, this can be site upgradable. So Venny can come around and have extra detectors there. There are ports here on the side and on the left and the right side that allows us to introduce external beam. So for example, if you want to use a different IR source, we can configure the systems. This particular system has been used around the world in synchrotrons, wherein they use a very energized electron beam as a source of their spectroscopic measurement. This particular system can handle those kinds of experiments because of this external beam module. At the back, we have the IR source located in here. I'll show you a diagram of that later. And we've got the desiccant port in here. So one of the things with FTIR spectrometer in general, a lot of the optical components that we use inside the spectrometer are hygroscopic. And it is essential that we keep those components free from moisture. And that is why we have a desiccant in here. So the system is sealed and desiccated, and the desiccant is there to absorb any potential moisture that leaks in. Another potential configuration is for you guys to purge the system. So by purging, we are purging dry air or liquid or nitrogen gas, so that we purge any potential moisture inside the spectrometer. We've got an indicator here which changes from blue to pink when the indicator is already saturated. And one of the main differentiation of the Nicolet iS50 with other models of FTIR spectrometers that we have, such as the iS10 or the iS5, is the iS50 can cover from far infrared to UV to visible range. So far infrared, mid-infrared, near IR, and visible. And the reason why the iS50 can do that is because we can configure the optics inside the system. So other system will have a set optics, right? For example, it's only KBR, then that defines the spectral capability of the system. But the iS50, you have the ability to change the beam splitter. So this in here is the beam splitter compartment. And at the moment, you have a KBR beam splitter there, which is optimized for mid-infrared measurements. But shall you decide in the future, hey, I actually want to do far infrared measurement, then all you need to have is a beam splitter which will support far infrared measurements and a detector that will support far infrared measurement. That is the main configuration of the spectrum of the iS50. But having said that, the iS50 can grow, as you can see in this photo. This particular configuration now have an automated beam splitter exchanger. If you don't want to manually replace the beam splitter, like what I just said, you can have a robotic hand which automatically does that for you. And the advantage of that is that you no longer have to open, which means it will minimize purge time and all of that. So if your measurement is quite sensitive with atmospheric effects, then this will have the advantage of minimizing that. And one of the key module that's unique to the iS50, not in the market, has a module like this, is the built-in ATR. And I'll talk more a bit about this in the next few slides. ATR is the most common sampling mode nowadays because it's a lot easier. Traditionally, you have to grind your sample with a KBR, create pellets or discs using pellet presses, and that requires skill to create pellets, right? And sometimes you create such a blurred pellet, and that will affect the quality of your data. But because of the advent of an ATR accessory, anyone could pretty much perform an FTIR measurement without having much skills. All you need to do is put your sample under here and apply some pressure to make sure there is a good contact between the crystal and the sample, and then voila, you can generate a good quality FTIR spectrum. And there's a lot of unique and novel features in this particular module, and I'll discuss that in the next few slides as well. Aside from that, another thing that's quite unique with the iS50 is this is the only ones which supports in-sample Raman module. So I'm not sure if you're familiar with Raman, a spectrometer, but Raman complements FTIR. So it generates an information, a spectrum which complementary to infrared spectroscopy. So typically what's a good infrared sample is not a good Raman, whereas a good sample which generates good Raman data is not a good infrared. So if you got having an infrared in a Raman system is quite sort of universal in terms of generating vibrational information from your sample. And I'll talk more a bit about the Raman later on. Now, what you're seeing outside is plastic casing for aesthetic purposes, but underneath that, we've got magnesium alloy housing, and you've got all the neatly designed and engineered optical components, as you can see there. What we have here, I will start from the IR source. So in this area here, we've got the IR source. So this particular system is already configured from fire IR to visible. So we've got our IR source here coming from in here. We've got filter wheels, which allows you to control how much energy goes to your sample, to the interferometer. We've got here the optional beam splitter exchanger. We've got some aperture there. And in here, you're seeing a diagram or the schematic of the built-in ATR. And in here, we've got the detectors. So in here, you can see the photo of the 3 detectors. If this is the MCT detector, you've got the in-gas detector and the DTS detector. And you can see how neatly and organized this particular model is. Right? Beam path. What happens to the IR and when does it go through your sample? So your IR beam or the light beam starts from your IR sources, which is this 2 modules here. It goes to a few mirrors. This is the interferometer, which modulates the beam. You've got the beam splitters here. So this is the active beam splitter. And if you've got spare beam splitter for other spectral range, we have beam splitter compartment. From your beam splitter, it goes through some mirrors, and we can direct the beam to either externally, if you've got an external module, or we can direct the beam to the ATR accessory, such as in this case. I'll show you how that works later on. Or we can direct the beam to the main sample compartment. And that's where the IR interacts with your sample. And then after interaction from your sample, we've got the detector. So depending on the spectral range or the type of application that you do. Another thing unique with the Nicolet iS50 is the use of Polaris light source. We're the only one who uses that in the market. It's a silicon nitride technology. One of the main features of that is it's stable for up to 10 years. We don't have the problem of hotspot migration. So if you can imagine a bulb, a light bulb, typically when it's new, you've got the hotspot in the middle. But as time progresses, that particular hotspot migrates to the side, and that causes decreased intensity to your sample. We don't have that issue with the silicon nitride Polaris light source. And that is why we give 10 years warranty on your light source. So if it dies within the next 10 years, you just get replacement. That's unique to the Nicolet iS50. Having said that, just last year, all the other models from the Nicolet portfolio now comes with silicon nitride light source. Another thing that we highlight with the Nicolet iS50 is its hyphenation capability. The Nicolet iS50 can be hyphenated to, depending on what kind of accessories applications you do, to different modules. What you're seeing here is the Nicolet iS50 hyphenated to an FTIR microscope. When do we use that? So if you've got very microscopic particles that you can't see from your eyes, but you know they're there, and if you want to get an FTIR spectrum of that, typically that's when we use a microscope. Typical users who does that, like people from the forensic field, if they get microscopic evidences and they want to know what the identity of that sample, they use a microscope. If you're familiar with microplastic analysis, which is a hot topic nowadays, so they wanted to know how much microplastic goes into the water after degradation, from waste and all of that, they sample the water, they put it under the microscope, and they are able to identify what the polymer is and whether how toxic they are to aquaculture or even to us if we eat that. Another module that we can hyphenate with the Nicolet iS50 is a GC-IR module. So if you're familiar with gas chromatography, so a GC system allows you to separate mixtures of species, of gas species, right? So you heat up, just similar to what you plan to do with the TGA-IR. So GC allows you to, with the GC column, it can allow you to separate different species. And the eluent from the GC can be transferred to what we call GC-IR module. And in the GC-IR module, we've got a gas cell, similar to what you have on the TGA. And then you can collect an infrared spectrum of that. So after you separate the species using your GC, we can identify what those species are using the Nicolet iS50. And finally, an in-compartment TGA-IR. So with your TGA system, typically what do? You heat up the sample, and then you burn it, and then you've got an evolved gas. And gases evolve depending on the material, what temperature they burn, all of that. So what we do is we transfer that evolved gas using a transfer line, as you can see here. That transfer line is also heated, and it goes to what we call the TGA-IR sampling accessory. And inside the TGA-IR module, we have a gas cell. So your evolved gas goes into that, and then we collect. We let the beam pass through that gas cell, and we try to identify what they are. And we can do this using ohmic series. So we can monitor the evolution of gases as it gets burned from your TGA-IR accessory. So it is quite powerful if you want to deformulate a particular sample that you don't know what the composition is, and if they're temperature sensitive. So microscope operations has never been simpler with the iS50 because of touch point operation. We can program the touch point. So when we connect this with a microscope, there is a corresponding touch point in it. So switching optics, you no longer have to dwell with going through the software. All you need to do is touch a button, and we'll redirect the beam path from the FTIR spectrometer to the microscope's objectives. It uses the same light source, and it can mount it either on the left side or the right side, depending on your bench configuration. TJIR, with the use of, in combination with the built-in ATR accessory, you can almost always have the TJIR in the sampling compartment. Back then, you will have, like if you do ATR or TJ, you will have to pull out the TJ accessory in order for you to do standard FTIR measurement and then put it back in when you need to do TJIR. But now, because you have a built-in ATR, the TJIR, if that's the only thing the main thing you do, it can almost always stay in here, right? And as I mentioned earlier, using Omnic Mercury software, which is an add-on to the standard Omnic software, we can collect evolution of gas with time, right? So TJ FTIR is made easier. So what I've talked about in the last, the three things that I've talked about, microscope, GCIR, and TJIR, they're what we call hyphenated modules. What's new with the Nicolet iS50 are dedicated modules that can work with it. So I've talked a bit about this already, but I'm going to discuss a bit more in details what they are. So the first thing that we highlight is the built-in ATR. Are we all familiar with an ATR accessory? Yeah, we've used it on your other system. So the built-in ATR module also comes with a touch point. So switching from the sample compartment to using the built-in ATR module is as easy as touching this button. If I click this one, you heard that mechanism? It redirects the beam path through the sample compartment, and it also sets your Omnic to use that particular detector. And if I click that one, it redirects the beam path to that mechanism is a mirror pathing, which redirects the beam path. Either it goes to the diamond crystal or it goes to the sample compartment. Some of the key features of the built-in ATR module is we use a monolithic diamond crystal. We don't use composite layers. It's cheaper to use composite layers when you have diamond on top and zinc selenide on the bottom. But the disadvantage of that is the zinc selenide cuts off your spectral range. Zinc selenide cuts off at 650. But because we use monolithic diamond, you don't have the spectral range cut off. Diamond does not have any cut off. It can typically goes down to 0. So you're not limited by the crystal itself. You are limited by the optical components. So this particular accessory comes with its own dedicated detector. It doesn't use these detectors in here. It has its own separate DTGS detector, which allows you to go to far infrared measurement provided that you have the right beam splitter. Majority of the iS50 we sell, probably 80%, comes with a built-in ATR module. So I mentioned about the touch point and the ergonomic design, industrial design of the pressure point. This particular pressure tower is equipped with slip clutch, so you cannot apply overpressure. I can twist it as much as I can, and I won't break it. That's designed for ruggedness, and you don't need to measure pressure force or anything like that. The idea with the ATR is, on top of the crystal, we have a very thin layer of IR light, roughly around 2 microns. Right? That's why we need to have a pressure tower, especially for solid, to make sure that there is a good contact between the sample and that thin layer of IR light. I mentioned about the dedicated ATR detector that we have here. In order to go down to far IR, traditionally you will have to do 2 separate collections. But because of the dedicated FTIR, we can go down to far IR without having to do 2 separate collections. It's automatically from far infrared to mid-infrared, we can have that, provided that you have the right beam splitter. We've talked about the monolithic diamond. We use all reflective optics. We don't use lenses in order to focus beam, because typically, sometimes when you use a lens, you lose some energy. With this one, we use all reflective. And I mentioned about the DTGS detector. And what you're seeing here is the diagram. When you press that button or you switch from the sample compartment to the built-in ATR, we've got mirrors, or we use a mirror technology, which allows the beam to go through the ATR crystal or to go through your sample compartment. And it's a matter of touching those touch points. Aside from that, we have kept the traditional sampling compartment design. So if you've got existing accessories from your old system, the Nicolet iS50 will support any standard, not just Thermo branded accessory, but if you've got third-party accessory supplier, we can support that. Or they typically make accessories for the Nicolet AS. And these are just some of the few quite popular ATR accessories in the market. The next module I'll talk about is the Raman module. So if in the future there's a need for Raman spectroscopy, the Nicolet iS50 has a Raman module. And it uses a 1064 nanometer laser. And the reason behind that, 1064 is generally free from fluorescence for a lot of samples. Fluorescence is a typical interference that you want to avoid with Raman spectroscopy. We choose 1064 aside from being able to do Fourier transform, but because to avoid fluorescence. The Raman module has a stage which moves, which allows you to do mapping, line scan, and if you've got multiple samples, we can do auto collection. So we've got array capability. Some of the features of the Raman module, it allows you to do point and shoot. It uses a 50 micron millimeter beam. So if you've got very small particulates, if you want to focus on that and collect a Raman spectrum of that, you can use the Raman module. I mentioned about the Omnic Atlas and Microview, give you the mapping capability. And we also have the Omnic Array, as you can see there, if you want to do a bit of automation. What's the future that the Raman module promises? So ease of use, you don't need any additional lab space. Typically, a Raman spectrometer will be as big as your Nicolet iS50, but in this particular case, it's essentially a sampling accessory that goes in the sample compartment. In terms of performance, it's short path length, and it's comparable to an external 1064 nanometer Raman spectrometer. And in terms of convenience, it's small beam size down to 50 microns, and it comes with all the turnkey softwares and all of that. I showed you a photo of the automatic beam splitter exchanger earlier, which will allow you to automatically switch beam splitter to accommodate different spectral ranges. That's the schematic diagram of that. Essentially, the beam splitter exchanger can hold as much as 3 beam splitter, and that will cover you from far IR to visible. Right? And switching between beam splitter is also a matter of touch points or setting what spectral range you want to measure, and the software will automatically switch or place the necessary beam splitter. So you can have as much as 3 beam splitter, and the switching between the beam splitter and the detector is also automatic. So if you've got a near IR beam splitter, it will automatically configure it with an NIR detector. We use all free mothers. Makes sense because we don't want oil to interfere in our beam because that will appear in the infrared spectroscopy. It's field upgradable. You don't have it at the moment, but in the future, shall you decide to have it, the system is ready to have it. And switching between different beam splitters is quite simple and fast. That's pretty much it. So that's the Nicolet iS50 FTIR spectrometer. It's designed for simplicity, and it's an all-in-one system which allows you to do near infrared, far infrared, mid-IR, in particular with mid-IR ATR accessory. We have hyphenation capabilities with the JC and TGA, and it's one of the unique systems which allows you to do in-sample compartment Raman measurements. And this particular configuration allows you to do measurement, essentially to deformulate, identify unknown substances, quantify amount of molecules as you're going to do with your evolved gases. And with the Raman, you can even analyze morphology of structures. And essentially, the software also allows you to generate seamless reports and things like that. That's it. The Nicolet iS50 FTIR spectrometer.